Viewers, and you're welcome to MLT channel. This is Engineer Oladipo, your host, and you are Amiable Online Tutor. In today's class, we are looking at physics, and the topic of discussion is actually physics alternative practical. This is meant for you guys that are preparing for WAEC, GCE, November, December, as well as NECO GCE. Precisely, we are looking at question 3, which is the electricity. Okay, now let's look at the question in details. So in the details, we have the circuit diagram, and the question read thus. Okay, without wasting much time, we have the question now. So the diagram above illustrates the connection of a battery, and here's the diagram, and here is the battery. A key, okay, here is the key, the plug key. Resistance box, here's the resistance box. And voltmeter, here is the voltmeter in circuit. The resistance box is set at different values of resistance R subscript I, where I equal to 1, 2, 3, 4, and 5, and the corresponding values of the voltage VI are read and recorded. Okay, figure 3A shows the values of resistance, and figure 3B shows the corresponding value of the voltage. Okay, now let's get figure 3A and B, and we have that here. Actually, this is figure 3A, and here are the resistance. Here are the value of the resistance. So scrolling that up, on it we still have figure 3B as well, that gives the corresponding value of the voltage, and here is figure 3B. Okay, good. So we are now good to go. So the next task is to now start the question. So in the first task from our figure 1, we have read and record Ri and the corresponding values of Vi. Okay, the moment external exam tell you to read and record, you must know that that is going to your table. So definitely the first quantity or parameter we have on the table should be Ri, and this is resistance. Definitely its unit, it will be in ohms. Then we are going to get that here on figure 3A. In the diagram in figure 3A here are the values of our resistance. Here is R1, R2, R3, R4, and R5 respectively. Then also we are supposed to read the corresponding value of the voltage. So that will be VI, and that will also be in volts. Voltage is in volts. And we also have the values of the voltage. We have it here on figure 3B. Okay, so we are done with Roman figure 1 of the question. So moving to Roman figure 2 of the question now. Evaluate R inverse, V inverse, and R inverse over V inverse. Okay, so R inverse now, that will be then the values of the resistance we've gotten earlier. So we do the inverse. So the unit of this will be per ohm. And also the value of the voltage that we've gotten during the course of the experiment, we shall get the inverse as well. And the unit of that will also be per volt. Then the last task on Roman figure 2 is to do the ratio of R inverse to that of V inverse. If you compute your unit very well, R inverse over V inverse, that will give you ampere. All right. And I think that's all on Roman figure 2. So this is what our table supposed to look like. This is what our table is supposed to look like. All right. We already have even the table that we just have to put the values. Okay. Now moving forward to Roman figure 3. Tabulate your reading. Oh, good. So to tabulate our reading, so let's get our table. Oh, we definitely need this. This is where we got our values from. So we have our table here now. we have our table here. I've already prepared the table ahead of the class. So we have the table. The next thing we need to do is just fill up the table. So according to the question, we are supposed to compute R first. So let this be R, Ri, then that will be in O. Then also Vi, then that will be in volts. Also we have Ri inverse, and that will be in per ohm. Also we have voltage inverse, that will be in per volt. And that wasn't good enough. And finally, we have the ratio of the R inverse to the V inverse. And I've said earlier, that will be in ampere. So make sure that in the exam, you put the correct title and the correct unit. So the first task is to get our R. And according to instruction, we are supposed to get our R on figure 3A. And precisely, if you are familiar with resistance bulbs, you should know that this is how the resistance box looks like. So for our first R1, for the first one, R1, here is R1, and the value of the resistance on the R1 is actually 1 ohms, because that's the only what's it called? What do we call this? Key that was open in the resistance box. So here will be 1, but we are not going to write 1 since practical. We write 1.00. Then the corresponding value of voltage at that point, here is it, V1. Then we have to read this. If from here to here is 0.5, that means here will be 0.25. Then here will be 0.75, 1.0, 1.25, 1.5. Then here will be 1.75. And there is 2.0. So that implies that each of these small calibration will represent 0.5. So if this is 1.5, no, is this 0.5? Yes. If this is 1.5, no, it will be 0.05. So if this is 1.5, this should be 1. Okay, let's see, 1.5 plus 0.05. Okay, so that should give us 1.55. So if this is 1.55, here is 1.6, here is 1.65, here is 1.7, okay, 1.75, that's correct. So this will be 1.8, this is 1.85, and this is 1.90. So the voltage will be 1.90. So each of those small calibration actually represents 0.05. Then to do the inverse of our R, 1/1, we don't need to stress ourselves on that. That will still give us 1. Then for when you are doing inverse, maintain 3 decimal places. That's the rule. Then to do V inverse, that will be 1/1.90. So to do that, let's quickly use our calculator. Where's my calculator? Okay, I have it here now. Okay, good. So I'll do 1 divided by 1.90. And what's that value? That's actually 0.526. So we have 0.526. Then also finally, we do our inverse, which is 1 over V inverse, which is 0.526. Then let's get the calculator once again. So now this time around we are doing 1 divided by 0.526. And what are we? Okay, that is 1.901. Okay, so we are 1.901. So that's how we are going to repeat this for the 4 other values. For the second R, our R is 2. So you have that here. And for the second V, if you have to read, here is V2. Then if here is 2.05, here will be 2.10. So here supposed to be, so here will be 2.00, and here is 2.10. Then you do the corresponding of R inverse, V inverse, and that simply with your calculator. Then for the R3, look at this where the plug key is open, that's 3.00. And what's the corresponding value of the voltage at that moment? V3. Here's our V3. So here will be 2.25. And if here is 2.25, then here will be 2.30. So this is 2.30, and that will be the value of our corresponding voltage when the resistance is 3. Then here is our R4, that is 4 ohms. And the corresponding value of the voltage at that moment here is it. So if this is 2.3, this is 2.35, and that will be 2.40. So that's 2.40. And finally, our resistance, which is 5 ohms for the last observation, and the corresponding value of the voltage at that moment for V5 is actually 2.50. So that's how you go about the table, and that should fetch you about 8 marks. Make sure in your table you have the correct title according to the instruction in the question, correct units, then maintain a standard number system. Here, for the values of R and V, I maintain 2 decimal places. Then for the inverse, I maintain 3 decimal places. So if you do that very well, we already have the table. I've already done that. We already have the table, the complete table for the question is here. And there is it. Okay, let me see. Let me clean all this so that I can place it. Okay, so now, so we have the value. Oh, I'm not supposed to move the screen. I'm supposed to move. So we have the complete table here. Here's the complete table. Just look at it. Here's the serial number telling us the number of times we are repeating the experiment. And there is our R in ohm according to the question. Take a look at that. According to the question, you are supposed to get R first. So then the corresponding value of V, we have them here, which are gotten from figure 3B. Then R inverse, that is 1 over your R. V inverse, that is 1 over your V. Then R inverse over the V inverse. And this is what you shall come up with. So we are done with the table. And if you look at, there is a trend. The R is increasing as it is going down. So is the V also increasing as it's going down. There must be a trend. Is that the values are increasing or decreasing? It must not oscillate. And if you look at R inverse over V inverse, also what happened to the value is that it is decreasing, that is coming down. So that trend is okay. So the next task after we are done with the table is to actually plot the graph. So what they want us to do on the graph, they said plot a graph of R inverse over V inverse on the vertical axis, then against V inverse on the horizontal axis, starting both from origin 0, 0. Okay, let me keep in here. Nowadays, WAEC use abscissa and ordinate. So abscissa is always your x-axis, while the ordinate is always your y-axis. Okay, now let's go to the graph. Then before we go to the graph, take note, the values that you are plotting, you have to extract them and place them on top of your graph sheet, at the top right hand corner of your graph sheet, so that you won't need to be flipping back and forth before you get your values. Okay, so now we should have the graph sheet here. Good. So we have the graph sheet, and I've already, okay, let me use my sniping tools to further make that clearer to you. Okay, good. So I've already placed my value of R inverse to V inverse on my graph sheet, as well as the corresponding value of V inverse also on the graph sheet. You're expected to do this, although you are going to do it horizontally. But because this is a virtual graph, that's why I put it to be vertical. Then make sure you label your axis. Okay, I've labeled my vertical axis, which is R inverse over V inverse with the unit in ampere. That will fetch you some marks, maybe about half mark or 1 mark, thereabouts. Then V inverse, I've also labeled that with its respective unit. Then I indicate here the starting point as stated in the question, origin 0, 0. So the next thing you need to do now is to actually put the scale, the title. Then the title, this is just a graph of, here is a graph of R inverse to V inverse along the vertical axis against V inverse on the horizontal axis. You can place your title like that. A graph of R inverse over V inverse on the vertical axis against V inverse on the horizontal axis respectively. Then later after your title, the next thing is you have to write your scale. And the rule for scale is that the scale that you are choosing must cover at least 2/3 of your entire graph sheet. So if here is my entire graph sheet, I'm going to make sure that the scale I'm choosing, then how do you do that? You just test the range of your values. Take for instance, the maximum value of R that I have is 1.9, while the minimum value is 0.5. So I can just use 2 centimeter to represent 0.5 units, which will be ampere on the vertical axis. Each of these boxes is actually 2 centimeter. So here I put 0.5 here, since I said that my scale on the vertical axis is that 2 centimeter to 0.5 ampere, because the unit of the vertical axis is actually in amperes. Okay, good. So let me just complete that. So if that is 0.5, then here will be 1.0, then here will be 1.5, and there will be 2.0. Okay, good. So then I'm going to repeat it. For the horizontal axis, I'm going to check what is the maximum value that I have, that is 0.526, and what's the minimum value, that's 0.50. Okay, I have to be logical here, because the interval is not much. The interval between the maximum value of V inverse and the minimum value is around 0.026, which is very small indeed. So what can I do? I can just say, I can just say that here is 0.5 now. So this will be 0.51, this 0.52, 5, in fact 52. That will make it to be too short, because highest I'm going is 0.52. So I can just make it to be 0.5 now. So 0.51 and 0.52. Okay, I'll still go beyond 0.5. Okay. probably I can make it to be, oh, there must be mistake on this value. There must be mistake on this value because I can see that the trend is no longer here. This value was increasing until, okay, the value is not even, there is no trend, increase, decrease, increase, decrease. The trend is not correct. So let's check the correct value on the table. Let's look at the correct value on the table. Okay, I have the value now. I have the value on the table now, which is actually different from the value that I have over there. So let me pick that value. Excuse me. So let me pick that value of V inverse and put it back. Okay, I have that. So let me change that on the graph sheet. Okay, the first value of V is 0.526, that was correct. The second value is 0.476, that was also correct. I think from the third value, all those ones are incorrect. So for the third one now, that is 0.435. Then the next one is 0.417. And the last one is 0.400. Okay, I think we are good to go now. Okay, now plotting the graph. Oh, okay, let me bring the values here as well. So the first is correct, the second is correct. The second is 0.435. The next is 0.417. And the last one is 0.400. So now we are now going to plot. Okay, so with this, we are moving from 0.4 to 0.526. So we say that here is 0. Let's say 0.2, 0.4, 0.6. That will not be too large enough. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. I think this is okay. We can manage this. So we use 0.1 to send that to 0.1 on the horizontal axis. So here will be 0.1, here is 0.2, here is 0.3, here is 0.4, then here is 0.5, and finally we have 0.6. Now the next thing is to plot the values. When R is 1.9, V at that moment is 0.526. So 0.9, 0.901. If this is 0.5, is sorry, if this is 1.5, this is 1.6, 1.7, 1.8, 1.9. So 1.9 is here. Then 0.526. If this is 0.5, this should be 0.52, 54, 56, 58, 0.6. So 0.524 here. Then going to 2, so our point is supposed to be somewhere, supposed to be here. So that's where our value is supposed to be. Then the next one now, the next one, we have R to be 1.05. And 1.05, this is 1. We cannot actually have 1.0, we can only have 1.1. So 1.05 can be represented to 1.1. And this is 1.1, 1.2, 1.3, 1. So here is 1.1. So what's the corresponding value of the voltage at that moment? 0.47. So each year, okay, let's put the scale on the horizontal axis. We have 2 centimeter, and that is to 0.1 per volt. So going to 0.476. So here is 0.4, and each one here represents 0. So this is 0.42, 44, 46, 48. We can have 0.476, but 0.476 can be approximated to 0.48 on the graph, which you can have. So here will be the value. So if you look at here, then this one is coming like this. So then here is our point. Here's our point. So you can use multiplication, you can use addition, you can use dots to mark your point, but don't use asterisk. Then the next one is when R inverse to V inverse is actually 0.76. And where is that? If this is 0.5, and we have said each line here represents 0.1. So this is 0.6, 0.7. 0.76 can be approximated to 0.8 on the graph, so we are going to use here 0.8. And what's the corresponding value? Now, these are not correct. We have corrected all that. So the corresponding value is 0.417, which can be approximated to 0.42. And if here is 0.4, here is 0.42. So we are going this way, then coming like this. Then here will be our point. Good. So we are moving to the next one, which is when our R is 0.6. So 0.6, if this is 0.5, here is 0.6. And what's the corresponding value of the voltage at that moment? That is, I hope I've not omitted the value. 0.47. Do we do that? Oh no. Okay, I think we did that. Then 0.43. Oh, this is supposed to be 0.43. For the third one, supposed to be 0.43, not 0.17 that I did earlier. So 0.43, that is still approximated to 0.435. That can be approximated to 0.44. So if this is 0.4 to this 0.44. So as a 0.44 at that moment, we are going to 0.76, which is approximated to 0.8 on the graph. And if 0.6567, then this is 0.8 on the graph. So our point is supposed to be here. Okay, that's cool. Then the next value is when our inverse, when our ratio is 0.6, and here is where is 0.6, and the corresponding value of the voltage at that moment is 0.42, and there is 0.42. So we have this. Okay, now I remain the last value, which is when R is 0.5, and there is where R is 0.5, and the corresponding value of the voltage at that moment is 0.4, and there is 0.4. So now there is something they call line of perfection or line of best fit. Out of 5 values, Your line is expected, your graph is expected to go through 4. But if not for at least 3, 2, that means you are wrong. So if you want to pick line of best fit, we have to exclude this. So the graph can actually be like this. So that's our graph. Then make sure you extend it long a little bit. Then if you are to get slope, make sure that your slope cover at least 2/3 of your graph. The slope must not be too short as well. And there is the value of our slope. There is our slope and there is our graph. Okay, what we have done here, actually, let's put it on the virtual graph. Let's put that on the virtual graph. Okay, let me save this somewhere so that I can quickly put that on the virtual graph. Okay, that's cool. So quickly now, so we have the virtual graph now. So let's just now plot the value so that we can have our graph in a straight line. So labeling our axis, we have said that 2 centimeters should represent what I think let me check. The scale 2 centimeters represents 0.5 amps. 0.5 amps on the vertical. So here will be S should be 0.5. So here will be 1.0. So here is 1.5 and there is 2.0. Okay, good. Then on the horizontal axis, let me check the scale that we use on the horizontal axis. To send that to 0.1 per volt. Okay. So 2 centimeters to 0.1. So there should be 0.1. Then here is 0.2. Then here is 0.3. Here is 0.4. Here is 0.5. And finally we have 0.6. And I've labeled my axis. This is the horizontal axis V inverse, and ratio of R inverse to V inverse, that's the vertical axis. I've labeled my axis. Now plotting a point without wasting time. So I'm just going to plot the points quickly. So the first value, when the ratio is 1.9, which falls to the second line before 2, the corresponding value of V at that moment is actually 0.526. Okay, that should be somewhere around here. Okay, so we have our first point. Then the second one, when R is 1.05, which we approximate it to 1.1, and that fall here. You have 1.1 here. And where you have 1.1, the corresponding value of V at that moment is 0.47, which we can't have, but we can have 0.48, and there is 0.48, because each value here represents 2 centimeters. So going forward now, then this come here, then this also come here. So we have our point here. Good. Good. So the next one is when our R is 0.76, and that will be approximated to 0.8 on the graph. This is 0.5, 0.6, 0.7. So here is 0.8. Here is 0.8. The corresponding value of the voltage at that moment is 0.43. So which can be approximated as 0.44. And you have 0.44 here. So we are going up like this and going like this. So here we have our point. Good. Okay. So moving forward, when our R is when the ratio is 0.6, here is 0.6. Then what's the corresponding value of the voltage at that moment? 0.417, which is approximated to 0.2. And here is that. Here is 0.2. And here is 0.6. So our point is here. Okay, good. And finally, when our R is 0.5, here is 0.5. Oh, here is 0.5. And the corresponding value of the voltage at that moment is 0.4, and here is 0.4. So definitely our point is supposed to be here. All right, that's good. So we have all our values now, and the next thing is just to plot our graph. Yeah, exactly. So just make sure you look for line of best fit, and I can have that here. The graph can actually touch. I want it to touch 4. Okay, good. These do not really touch 4, so I'm not going to start from that point. Let me start from up. Let me start from up here. Exactly. Okay, I think that was cool enough. Then I can extend this. Oh, I don't need to extend that. Then let me get my slope. And that's all. That's what you are expected to do. The juice you could just add is to put your scale, as I've explained earlier on the sniping tools. You make sure your scale, make sure your title, make sure you put your title, and that's just the graph, and we are done with the graph plotting. Okay, now what else do we have left in the question? Apart from the graph, determine the slope of the graph and intersect C on the horizontal axis. Okay, to do the slope, you just need to do change in the vertical over change in the horizontal. Okay, I think I can do that here. The formula of the slope, don't do your slope on the graph. Make sure you do it on your answer booklet. Change in the vertical, and on the vertical I have R inverse over V inverse. So I'm going to do change in that over change in the V inverse. And that will give me S equals to, which is slope, that is R inverse over V inverse 1 minus, sorry, not 1, 2 rather. R inverse over V inverse 2, which is the highest value, minus R inverse over V inverse 1, then everything over V inverse 2 minus V inverse 1. So that's how you're supposed to, that's the formula. Then to get your slope now, so to get the values of your V2, V1, and then, so here now, look at the maximum value here. This point is your ratio 2. That is your R inverse over V inverse 2. Then this point will give you your R inverse, pardon me to just use R over V because of time, over V inverse 1. Then coming down, there will be your V inverse 2, and there will be your V inverse 1. So the next one is just simple arithmetic, to get your answer. And you have to read this on the graph. This is 0.52556. Your V2 is 0.56. This is equals to 0.56. 0.56 per volt. And your V1 is obvious, that's on 0.4. That's 0.40 per volt. And if you look at your ratio, which is R inverse 1 over V inverse 1, that is actually equals to 0.5, is obvious. Then the final of it, you can trace it. Each line here represents 0. So this is 1.6, that's 1.7, that's 1.7. So just substitute that into your formula, and if you substitute that into your formula, you can quickly calculate your slope, and that's how to get the slope. Then also, going forward on the question, the intercept. Okay, intercept is the point where your graph cuts the vertical axis. But unfortunately, here the graph cannot cut the vertical axis on the positive side of the vertical axis. So it will cut on the negative side if this thing keeps extending. So instead of doing that, even if your graph cannot do that, you can actually use formula method of your mathematics to do that. Don't forget, in your mathematics, we were told that the equation of a straight line is equals to y is equals to mx plus c. So this m is actually your slope. The value you get in your slope, you substitute it here. Don't forget, this is what you are looking for, which is the intercept c. Then you pick any value on y. Let's assume that we pick 1 point. Let's assume that we pick 1.5 on y. Then you pick the corresponding value on x. So that's how to get your intercept. Then moving forward again, what next? Okay, evaluate k is equals to d1 over d2 multiplied by square root of your slope. Okay, I don't know what d1 and d2 is in the question because that was not captured at all, but so we have to just skip that question. Then state two precautions that are necessary to ensure accurate result when performing the experiment. Okay, for the precaution, you have to mind your tenses because you are not the one that performed the experiment, so you are not expected to put your tenses in past. You put it in future because, so like I can say that my first precaution is that I would ensure, because if I'm the one that performed this experiment, let's see the diagram. I would ensure that I remove the battery. I remove the plug key rather. I will ensure that I remove the plug key when the battery I ensure that I remove the plug key when not in use, when you are not taking your reading, in order to avoid cell rundown, so that your battery will not run down quickly. Then also, apart from that, you can ensure tight connection. I would ensure that I have tight connection at the terminals to allow free flow of current. And you can also avoid parallax error on the voltmeter when you are taking your readings. Okay, so that's that about the precaution. Then what's the final aspect that we have in the question? Okay, state two factors that can affect the resistance of the wire, where the area of the wire can affect the resistance of wire. Then the length of the wire can affect, and also temperature can affect. Then you have a simple calculation that you just have to simplify here. A 3 ohm resistor in series with a combination of 2 ohm resistor in parallel. Calculate the current in the circuit if the PD is 6 volts. That's a very simple one. You have 3 resistors, but that means your R total will be R parallel plus R series. Out of these 3 resistors, one of them is in series, 3 in parallel. The 2 that are in parallel, you can use combined resistor to do that. So you can just say your RP, that will be R1 multiplied by R2 over R1 plus R2. That is combined resistor. So that can just be 3 times 3 over 3 plus 3. So that gives you your resistance in parallel. Then your resistance in series, that's 3. So the value you get here, you add it together, that gives you the resistance total. Then use your formula that V is equals to IR. Ohm's law says V is equals to IR. And you already have the potential difference. Just make I the subject of the formula. All right, that will be all for the practical session for physics. All right, if you have gained 1 or 2 things, don't hesitate to join us for the other practical session for chemistry, for biology, and so on and so forth. Okay, 45 minutes just gone on, like 45 seconds. Well, our virtual classes are ongoing. You can join our virtual classes with just a token amount. And we have our physical classes also ongoing at Omega Building, Obafemi Awolowo with Malete Ibadan. Then for our online classes, you can use our website to know more about us. And the website is www.mlttutors.wordpress.com. And you can also reach out to me via my telephone line for inquiry and to book your wards or your children for private one-on-one session, home tutoring, online class, and physical class as well. So you can reach out to me. My WhatsApp line is 080-670-76871. Until I come your way again, I remain my humble self, Engineer Oladipo, your host and your amiable online tutor. Bye for now.